Okay, here we go. The Rodriguez family and the Jacobson family go to the movies together. The Rodriguez family bought 3 adult tickets, 2 youth tickets, for a total of $29. The Jacobson family bought 2 adult tickets, 5 youth tickets for a total of $31. Let X represent the cost of an adult and Y represent the cost of the youth. Do you notice as I was going through that I was kind of like circling and underlining important information? It just makes it easier for when I have to go back. So what it's saying is write an equation to represent the Rodriguez family. Well, we know they bought 3 adult tickets. What's standing for adult tickets? What letter, what symbol is standing for adult tickets? X. So 3X, we bought 3 of those. Plus, what else do we know about them? The Rodriguez family, what else do we know? What else do we know about them? They bought 2 youth tickets. And what's standing for youth? Y. And then all this together, what do we know? If we put all this together, what do we know about that situation? It equals $29. That's our equation for the Rodriguez family. I want you to try to write the equation, mimic exactly what we just did, for the Jacobson family. Read through, here's our Jacobson family. 2 adult tickets, 5 youth tickets for $31.25. Who's got an idea for me for the Jacobson family? What equation could I write? Very good. Looking at this situation, would elimination method or substitution method be the best? What do you think? What do you think? I mean, if we do substitution, I'm going to have to get X or Y on a side by itself. To me, that seems like a lot of work. What I would say when it's set up like this, I have X, Y, and a total. I would say the best method to use is elimination. So now we're going to solve it. So I'm just setting them up over top of each other again. Can I eliminate the X's as they sit? No. Can I eliminate the Y's how they are? Can I turn the 2 into a 3 by multiplying? Can I turn the 3 into a 2 by multiplying? Can I turn the 2 into a 5 by multiplying? What about the 5 to a 2? I can multiply 5 times 2 and get, or 5 times something and get 2. So it means I have to multiply them both. Now, what do most of you do? Because I watched you do it. What do most of you do in this situation? What am I going to take this top one times? I've seen you guys do it. What are you going to take this top one times? Two. Then what are you going to take this bottom one times? 3. But now, hold on a minute. That's going to make them both positive 6, right? And we need one of them to be what? So pick one to make it negative. Which one should you want it to be negative? It doesn't matter. Pick one. The 3 or the 2? Okay, fine. It doesn't matter. So now we distribute to everything. So, Brennan, this is actually what you missed last week. This is called elimination method. We distribute this to everything. Okay. Now can I eliminate? What eliminates now? Tell me, what eliminates? The 6s. They're opposite, because if I have positive 6 and negative 6, I get to 0. That's why it eliminates. So I add down now. 4 plus negative 15 gives me negative 11. 58 plus negative 93.75 gives me negative 35.75. Oops, I forgot the negative. And what's my last step here? Divide. Is it okay to get a decimal since we're talking about money? Yeah, that would be normal. That'd be all right. But what does Y stand for? Adults or the children? The children, the youth. So we say, okay, I'm going to tell you over here, youth tickets. What are they? How much? What did we just figure out? How much is a youth ticket? How much should we just figure out a youth ticket costs? $3.25. Now we got to figure out an adult ticket. So I'm going to take this guy and put him in for Y. Doesn't matter which equation I do it in. No. And I solve. 3x plus 650. And now I'm just balancing. I'm going to divide that finally by 3. And I get that X equals $7.50. So my adult tickets are $7.50. Notice I'm telling you over here what's what, right? I'm answering the question. So I got youth tickets were $3.50. Adult tickets were $7.50. Now what they're wanting us to do is check our answer. So I have 3, and my X is $7.50 plus 2 at $3.25 better give me $29. Then we need to check the other one too. We have 2 at $7.50 plus 5 at $3.25, and that better equal $31.25. So now you're just going to solve both sides, this answer, and add them together. I want you to try that, please. Oh, sorry. Erica, 235. Bus, 235. So I'm proving that both sides equal each other. All right, the Chang family also went to the same movie. The Changs bought 1 adult ticket and 3 youth tickets. What's the total cost? So I want you to figure out the cost for them. We already know what each, the adult and the youth tickets cost. Figure out how much the Chang family spends. Okay, so adult ticket is $7.50 plus 3 times 3, 25, and we want to know how much they spent. So what's 3 times 3, 25? What's 3 times 3, 25? 975. And if I add 750 to that, I'm going to add those two together. So the Chang family only spent $17.25. Questions? Okay, we're going to go ahead and switch gears over to that presentation I just gave you. Once Hayden gets back. Okay. All right, as I said, this is our last content objective. This is CO5. I can set up and solve systems of equations for real-world situations. I left this in here because I thought this was really good, helpful, just like, here's what to do. Carefully read the word problem and identify the important information, which I did in the last one. I was modeling that. I was showing you what I do. Determine what each variable represents. Write 2 linear equations that represent. Now, here's the difference. The one that we just wrote was ax plus by equals c, where a, b, and c are all numbers, right? Is that what it was like in the Rodriguez family? Then there's also going to be one where you can write it in y equals mx plus b, where m and b are going to be numbers. Notice this one only has 2 numbers. How many did this one have? 3. So that's kind of how you're going to tell. Okay? All right. I hope you guys wrote that down because I would have. All right, let's flip it over. Let's get started right away. All right. Now he's trying to decide between 2 different cell phone plans. Plan A charges a flat fee of $20 per month and 10 cents per minute to use the phone. How many numbers did you hear? 2. So that's why I told you I would have wrote this down, because when there's 2 numbers, it's going to look like this. When it's 3 numbers, it's going to look like this. Okay. So we heard 2 numbers there. Plan B charges 18 cents with no flat fee. If it's no flat fee, what number is that? No, if it's nothing. 0. No flat fee would represent 0. So I still have 2 numbers. How many minutes would Naya have to use each month for the cell phone plans to cost the same amount? How much is that cost? So what we're going to do is we're going to first write equations for this. Plan A, y equals. What's making looking at Plan A right here, Plan A charges a flat fee of $22 and 10 cents per minute. What is causing that cell phone plan to change the amount it owes? What's happening? How does their bill get more expensive on Plan A? when she's using it. So the more minutes she uses it, the more expensive it's going to get, right? So whatever's making it change is the first number you're going to use. It's 10 cents per what? Per what? Minute. Whatever's following the per minute, that's what the X represents. Now let's say she bought that phone, she got plan A, she turned her phone off and put it in the closet for a month. How much did that phone plan cost her? Look at plan A. How much did that phone plan cost her? She bought it, she shut it off, and she put it in the closet for a month and didn't use it. $22. If she didn't use it, I don't have to worry about the 10 cents, right? But it still cost her $22 to have it? Yep. So we have to add that $22. Now, plan B. What's making plan B cost money? Same as plan A, but it's when you're using the phone. But this time, how much is it? 18 cents per. So that's what X stands for. What's Y standing for in both of these? What am I trying to figure out? What per month, though? How much it charges, the cost. Okay. Okay, now when they're like this, or they're both set equal to Y, does it make sense to eliminate? No. In this situation, I would say substitution. When it has the Y equals mx plus b, I would always use substitution. I'm going to scoot this down and I'll show you why I would use substitution. We've got our two equations. It's saying y equals this, right? So can I just put that in for y right here? Yes. So I'm just going to put this in. And I'm going to balance. This is a positive 10 cents, so I'm going to get rid of it. I'm going to subtract it. Opposites do what? Cancel. Whatever I do to one side. What's 18 cents minus 10 cents? 8 cents. What's the last thing you need to do? Divide. And that is not something I know off the top of my head. $275 what? What does X represent? No. What did we say X represent? I wrote it down at the top. What did it say it represented?
Minutes.
Minutes. So 275 minutes. If they talked for 275 minutes, the phone plans would be the same. But now they want to know how much it would cost them to. So we're going to find out how much is it going to cost at both situations. So we're going to multiply them both, and we're going to figure it out. I'm going to start here. 18 cents times 275. I want everyone to type that in. $0.18 times 275. What do you get? Say it. What do you get? I bet you forgot to hit the decimal in front of the 18. But the numbers are right. $49.50. This should equal the same as this. Let's find out. Take your 10 cents times 275. And then I want you to add those together and tell me what you get. For $27.50 plus 22, what do you get? What did we get? $49.50. So we're saying at 275 minutes, both cell phone plans cost the same at $49.50. Do you notice how I'm labeling this with minutes? I labeled this with dollars. Am I going to expect that you label? All right, let's go to the top of the next page. I want you to just see if you can write up what it's saying. Tamara chooses one of two plans for the gym. So we're just switching from cell phone plans to gym plans. She can become a member for $80, then pay $25 per month. How many numbers did you hear? 2. Or she can pay $45 without becoming a member. So without becoming a member would be that 0. I want you to see if you can write the equation. There's 2 equations. I would recommend they start with y equals. All right, what did you come up with one equation? Y equals? What's making her gym plan change? It's costing her $25 per month. So that X is standing for month. But it costs her $80 just to be a part of it. The other one, what's making her cell phone plan or her gym plan change, is $45 per month. The only difference is she does not have to pay a gym membership. So do you see how they're both set equal to y equals? I'm going to use substitution on that. I'm going to substitute this in for this y. I'm going to subtract 25x, subtract 25x. Opposites cancel. What's 45 take away 25? 20. Very good. So what's my last step you think I need to do? Divide by 20. So x equals what? 4. And what does x stand for? Months. So at 4 months, they would cost the same. If I want to know how much that is, I'm going to put 4 in for x and solve it. What is 45 times 4? $180. So in 4 months, she will have spent $180 at the gym, and it will cost the same. Again, do you notice I'm labeling? We're actually going to skip example 2, which is going to be skipping a lot of slides. So we're going to jump all the way over to example, right above example 3 where it says Paula. Okay, as I read through this, I would do exactly what I do. Paula bought 4 shirts, 3 pairs of shorts for $134. How many numbers did you hear? Her sister bought 2 similar shirts, 3 pairs of similar shorts for $100. How many numbers did you hear? 3. So am I going to use y equals mx plus b? Nope. I'm going to use that ax plus by equals c, where a, b, and c are numbers. So 4, what do you suppose x is going to stand for? What is it? For what? Shirts. Plus 3y, what do you suppose y is going to stand for? Shorts. Equals $134. Two x plus 3y equals 100. Do you see how we did that? Okay. I'm going to set them up over top of each other because when it's this way, you're going to want to use elimination. Do you see what I see when I set it up that way? Can you eliminate the x right now? Can you eliminate the y right now? Can I do something really easy to the y? What could I do? Times it by what? -1. So I have -2x -3y equals -100. What eliminates now? Nothing? 3y's. They're opposite. 4 plus -2. What does that leave me with? $134 plus -100. What does that leave me with? Okay. And the last thing I need to do is, So how much is one shirt? So there's my shirt. What about now my shorts? What should I do? Does it matter which equation I put it back in for? No. So 2 times 17 is 34. Yep. I'm going to subtract my 34. And final step would be to do what? So my shorts are $22. Okay, normally we would take time to check it, but we just don't have that kind of time right now. So what we're going to do is we're going to look at this example 3. The school that Stefan goes to is selling tickets to a choral performance. On the first day, the ticket sales sold for $3 for senior citizen tickets and $1 for child, totaling $38. How many numbers did you hear? How many numbers did you hear? 3. The school took in $52 on the second day by selling 3 senior citizen and 2 child. How many numbers did you hear there? 3. So I'm going to use the AX plus BY. Day 1, 3X. What's the X standing for? On the first day, ticket sales for the school sold 3 senior citizen tickets. So what's the X standing for? The senior citizen tickets plus 1Y equals a total of 38. I want you guys to write day 2's. What would day 2's equation look like? Who can tell me day 2's? What do you got for me? How many senior tickets were sold on day 2? 3X plus how many child tickets? Equals? Very good. Tomorrow, I am gone. I will have an education video for you to watch first, and then a
Honestly,
stuff to do.
keep it in lab.